The crisp mountain air carried the faint scent of pine as Edwin Hubble adjusted the eyepiece of the 100-inch Hooker telescope at Mount Wilson Observatory. Beneath the starry expanse, the young astronomer leaned into his task with fervor. Each turn of the lens brought distant galaxies into view, their faint light captured after millions of years of travel. Yet tonight was different. Hubble wasn't just observing stars, he was tracking their movements. Through careful measurements, he noted something extraordinary. Faint spectral lines emitted by these galaxies were shifted toward the red end of the spectrum, a phenomenon known as redshift. The implication? These galaxies were not stationary. They were moving away from us. The farther they were, the faster they receded. The universe, it seemed, was expanding. Hubble straightened up, his mind racing. What did this mean for the cosmos? What lay beyond the boundaries of the visible universe? If the galaxies were rushing outward, could there be a definitive edge, a boundary where everything stopped? Or was the universe infinite, its mysteries stretching beyond comprehension? Hubble's findings were a revelation, and they shook the foundations of astronomy. Until that moment, many scientists believed the universe to be static, unchanging. The discovery of its expansion was as if an ancient tapestry had begun to unravel, revealing threads of an entirely new narrative. To understand this expansion, cosmologists turned to the metaphor of a balloon. Imagine dots painted on its surface. As the balloon inflates, the dots drift apart, not because they're moving, but because the surface they rest on, the fabric of space-time, is stretching. Galaxies, like those dots, recede not through space, but with space. But this raised profound questions. If the universe is expanding, what is it expanding into? Is there an outside of the universe, or is this boundaryless growth a feature of some deeper reality? If the universe has an edge, what lies beyond it? If infinite, how can we even begin to grasp such a concept? Philosophers and scientists alike have wrestled with these questions for centuries. In antiquity, thinkers like Aristotle envisioned a geocentric cosmos with celestial spheres encasing the Earth. Beyond the outermost sphere, Aristotle suggested the prime mover, a divine, eternal force. The medieval mind, influenced by religious dogma, imagined heaven or an endless void beyond the stars. By the Enlightenment, perspectives shifted. Astronomers like Johannes Kepler and Isaac Newton laid the groundwork for a universe governed by natural laws, but even they skirted the edges of what lay beyond. Infinity, they understood, was a concept that stretched human comprehension. Modern science, armed with equations and telescopes, has pushed these boundaries further. General relativity, Einstein's crowning achievement, describes the universe as a dynamic entity where space and time are interwoven. Its equations allow for a finite yet unbounded cosmos, a universe that wraps around itself like the surface of a sphere. In this model, traveling far enough in one direction might bring you back to your starting point, much like circumnavigating the Earth. But what if the universe is truly infinite? The idea defies human intuition. How can something have no beginning or end? For centuries, mathematicians have struggled with infinity, a concept that is paradoxical yet indispensable. Could the universe itself be infinite, its edge an illusion of perspective? The implications of Hubble's work reverberated across scientific disciplines. If the universe is expanding, it must have had a beginning, a moment when everything was compacted into an unimaginably small and dense state. This idea later became the foundation of the Big Bang theory. But even this explanation leaves us dangling on the edge of comprehension. If the universe had a beginning, what came before? Stephen Hawking, in his no boundary proposal, likened the universe to the surface of a sphere, but added a twist. Just as the Earth's poles cap the planet without implying an edge, Hawking suggested the universe's beginning was not a boundary in time, but a transformation of dimensions. Asking what lies beyond the universe, he argued, might be as meaningless as asking what is south of the South Pole. Despite such elegant theories, the human mind craves boundaries. We imagine walls, thresholds, or membranes separating the known from the unknown. But nature often defies our instincts. Consider the horizon on the open ocean. It appears as a definitive edge, but traveling toward it reveals only more water. Could the universe be similar? Some scientists posit that what we perceive as the edge of the universe, its observable limit, is merely a function of light's finite speed. Light from distant galaxies has taken billions of years to reach us, but beyond this horizon lie countless more galaxies, forever hidden by the constraints of time and distance. Others propose that the universe could be one bubble in a vast multiverse, a sea of universes, each with its own physical laws. In this view, our universe might be finite, but the multiverse is boundless. What separates one bubble from another? String theory offers one possibility: higher dimensional membranes, or branes, that exist in a bulk of hyperspace. These branes might occasionally collide, birthing new universes in cataclysmic events like the Big Bang. To unravel the mysteries of the edge, scientists turn their gaze backward to the universe's earliest moments. The theory of cosmic inflation suggests that in the fraction of a second after the Big Bang, the universe underwent exponential expansion. Space-time stretched faster than the speed of light, smoothing out irregularities and creating the vast cosmic web we see today. But what sparked this inflation? What lies beyond its reach? Theoretical physicist Alan Guth, a pioneer of inflation theory, suggested that the universe's expansion could be eternal in some regions, creating pocket universes with unique properties. Could our universe be just one in an infinite froth of inflating regions? Why do we care about the edge of the universe? Perhaps it's because boundaries define our understanding of the world. They provide a sense of order, a framework within which we navigate existence. The idea of a boundaryless cosmos, one with no edge or an infinite expanse, challenges not just our physics, but our philosophy. Edwin Hubble's observations transformed our perception of the cosmos, turning a static, finite universe into a dynamic, expanding frontier. Yet, as we peer deeper into the void, the questions multiply. Does the universe have an edge? If so, what lies beyond? If not, what does it mean to exist in a boundless realm? As we stand on the precipice of understanding, we are reminded of the explorers who charted unknown seas, always wondering what lay beyond the horizon. The edge of the universe, like the edge of the map, is not an endpoint, but an invitation, a beckoning to delve deeper, to stretch the limits of thought and imagination. And so, the quest for the edge continues, guided by curiosity and fueled by wonder. Beyond the galaxies, the expanding void, and the shimmering light of distant stars, the universe keeps its secrets. For now.